perform an activity to investigate the relationship between total current through a parallel combination of resistors, okay, and the current through an individual resistor. So what is the question asking us to do? They're asking us to have a look at what current is flowing through each of this resistor, which are connected in parallel. As you can see, they are in parallel. They're sharing node A and B. Right? These are the two nodes. So they're asking us what is the relationship between current going through each of this and the current that is going through, coming towards them or going out of them. So it's something like that. So basically, what is the relationship between I and I1, I2 and I3? So if you guys recall this, right, have a look at it. So what did that we see? When we started the journey of this ball bearings, when we started looking at it, they were as a whole as one. So there are 4 plus 9 of it, right? So I guess I think 1, 2, 3, 4, 5 of it went this way and 4 of it went this way. So basically 5 plus 4 is 9. So current that is flowing inward, right, will get distributed not equally, can be equally or may not be equally. Majority of times it's not equally, but end of it, whatever is current going through individually, if you add them, it should be equal to this. It makes sense, is it not? If 10 amperes of current is going through the circuit, so here if it's 4 and say here it's 3, here it has to be 3 ampere, right? Because they should add up to 10 amperes and out goes 10 amperes again. Okay, so when 10 amperes goes in, they get distributed maybe not equally, maybe equally, and they come out as 10 again, right? So this makes sense, is it not? Because electrons are going in and coming out. The energy in the electrons will change, that is different. But the number of electrons will not change. Not in the circuit at least. The number of electrons will not increase or decrease. So the electrons will remain the same. So the count will remain the same. So whatever entered came out. Does that make sense? Okay, like this only. You can think of them as physically starting from one end to another end. In between, the energy or the speed reduces and it gets converted to sound or a bit of disturbance. If not, physically they won't disappear. Many people think that as and when they go through a resistor, the electrons get eaten up. They don't get eaten up. It's not like that. So what is being used up is the energy that they had. Right? You can think of it in that way. Now, to see this, started with this. This two is done. Now we are doing this. To see this, I have an experimental setup. So I have my multimeter set up to measuring 20 milliampere. That's the maximum it can measure when I set it to this. Now on the breadboard I have 3 resistors. It's tough to see because the connection was not, it was not that hard to make, but it's not very neat. Okay, so we can see, if you can guys see, this is my positive terminal and it's been connected to 1, 2 and 3 resistors at the same point, and the last from that side, this is the last, right, that is in connection with this, which is going in this way, this wire, and it's over there. And the next resistor is somewhere else, but that connection is going, and basically all of them are in same line. So here they started same and here they ended up on the same line, means they are in parallel connection. And this black wire is your negative, right? It's the same circuit as what we have drawn above. So why is that I have done it? You'll be seeing that in the experiment. It's so that I can connect the ammeters in between. Okay, so I hope you guys had a good look. So I'm going to zoom out now. So similar to this, right? In between, I want to place the ammeter. I'm using a single ammeter. I'm not going to change the voltage. The source will remain the same. So the scenario will not change. And in between, I'm making this ammeter being placed. I'm placing them in between that. So how is that I'm doing? This is the connection that I've made, and again, I've done some connectivity that I can't show it now. As in, when you guys see, if you understand, good. If not, understand that I'm trying to place the ammeter in each of the circuit. So what your job is, you'll see three different readings, A1, A2, A3, related to I1, I2, I3. Okay, so basically it's three set of values, and the last value is the main current, I value. Okay, this is a sequence in which you will be going to read it or see it over here. So your job is to, again, please write it down, I1, I2, I3, I4, not I4, I basically. Please make a note of that. Okay, I hope you guys understood what you have to do and what is that we are looking at. So now you please watch the video. I hope you guys made a note of it. So what is the current through the resistor R1? Current across R1, measured current in microampere, milliampere. First happens to be 0.24, right? Second happened to be 5.30. Third is 0.53, and the end of it toggle between 0.06 and 5. So this is the average. So let's see what is I1 plus I2 plus I3. So I is the current that when it came from the main. You need not write it as I1 plus I2 plus I3. Main current, right? That makes sense. Now, what is I1 plus I2 plus I3? 4 and 7. Then 5, 10. One carry 6.07 microampere. This is approximately equal to 6.06 microampere. Make sense? Right? So, yes, this is true. So, in general, if I is the main current going into the loop, and I1, I2, I3 are the respective current through R1, R2, and R3, we can tell I is equal to I1 plus I2 plus I3. Is it not, guys? Does it make sense? You can think of, I mean, I think you guys have enough visual proof. Let me not drag it and bore you guys. So how do you write the answer? Same thing, apparatus 3 resistor. Maybe not 3 voltmeter. Sorry, this is not voltmeter, it should be ammeter. So single ammeter, or you can write whatever you want. Battery, key, connecting wire. Circuit, it has to be this way. Just to show. You need not have multiple ammeters, you can have a single ammeter. And you can show the I mean, answer that way, the way I did. Connect it at different points and show the answer. Anyways, this has to be a circuit diagram, labeling and all the positive and the negative and all of that. So this is positive and this is negative, right? Positive end of the battery, negative end of the battery. Procedure: connect, plug in the key I have not shown. Oh yeah, then I should be showing all of that. Let me do that. So let's have a voltage source. We're going to put the battery over here and the key over there. So I'm putting a battery and a key. Okay, so note down the current in all the ammeters, and I1 is fill in the blanks, and you should show that sum of I1 plus I2 plus I3 is equal to so many amperes. So end of it, we'll conclude that whatever we added, right, is equal to the main input current or main current. When resistors are connected in parallel to each other, the total current through a parallel combination resistor is not it is equal to the sum of current through each resistor of the combination. Right? Quite simple and easy to understand. The voltage is what is difficult. Current, everyone understands that. I've seen. Voltage is what you guys find it difficult. It's to do with work, you know. So it's a extension of your work topic. Okay, so now you can pause and make a running note of whatever you are seeing. From here, this is your answer to 3 mark question and all of that.